Everybody, I'm going to be talking about operating Opensearch on Kubernetes, how to deploy it, how I deployed it, some of the architecture principles that I followed, how it evolved over time. So before we begin, let me quickly introduce myself. I am Pratik Parikh and I work as a DevOps engineer at Simbian, which is a Silicon Valley startup working on cybersecurity using AI agents. I work as DevOps, I do cloud, CI/CD pipelines, working on networking, a little bit of cybersecurity as well, and managing the cloud, obviously, managing the infra. So I do all of these things. I also love to speak at events, so this is why it brings me here. I love Opensearch and I have used it since a long time, and I also love speaking at events. So last month I was at DevOps Days Atlanta. So basically, I love to speak at events, and if you also share my passion, definitely connect with me and at any time. When I'm not working, I'm reading a book, watching a movie, solving Rubik's cubes. So if you're interested in those kind of things, definitely do reach out. There is also a QR code on the screen. You can scan it. We can get connected on LinkedIn. So without further ado, let's begin. I will be talking about Opensearch, obviously, on Kubernetes. There is something called Opensearch operator. We'll look at what are operators, what is an Opensearch operator, how it works, how does Kubernetes allow you to deploy Opensearch in a nice way, and we'll look at some architecture evolutions that I went through for pushing Kubernetes workload logs into Opensearch. And if you have any questions, feel free to interrupt me at any time, but I would love if I could take the questions at the end or even after the session. So first things first, Opensearch on Kubernetes. Why? So Opensearch, as you know, powers our logs, metrics, analytics, telemetry, observability, the entire search experience. And Kubernetes, if you go by the definition, it is like an open source container orchestration platform. So many words, right? Kubernetes is essentially how you run modern day workloads, containers, microservices, and even Opensearch. But why would you run Opensearch on Kubernetes? First of all, it's fun, it's cool, you should do it. And if you're not convinced by this, I will go with a more serious note. So on Kubernetes, if you deploy anything, it is infra agnostic. It abstracts away everything. So whether it's your infrastructure, network, storage, everything. So once you deploy something on Kubernetes, it doesn't matter whether it's on-prem, your infra is on-prem or on one of the cloud providers, whether it is on Raspberry Pi, it doesn't matter. Ultimately, everything is abstracted away, so you don't have to worry about all of that. Next is with Kubernetes, it's very easy to scale. Whether you want to scale horizontally or vertically, using Kubernetes, it becomes very easy, and there are various tools out there which help you do the scaling. There are different number of ways you can do it. So Kubernetes, elasticity, everything is given by Kubernetes, so you don't have to worry about it. Next thing is, with Kubernetes, there are various tools, so things like Helm, operators, controllers, and basically all of these tools help you manage any workload you deploy on Kubernetes, especially Opensearch. And the main part is that when you use Opensearch, when you deploy Opensearch on Kubernetes, there is something called Opensearch operator, which we'll talk about in the next slides, and it basically helps you everything, right from deployment of Opensearch cluster to configuration, updates, upgrades, everything, even deletion if you wish to do so. Everything is done very seamlessly. So I would say if you are already using Kubernetes in your infra stack, deploying Opensearch on Kubernetes should be a no-brainer for you. Let's move on to the next slide. So let me quickly talk about some of these terms. So Kubernetes, as you know, has a lot of resources, things like deployment, stateful sets, daemon sets, services, ingresses. There are a lot of things. But one of the main powers of Kubernetes is that it is extensible. You can define custom resources. In these custom resources, it's up to you what you want to write there, what gets stored, what gets encrypted, not encrypted, and so on. So Kubernetes will help you define custom resources. There is something called CRD, custom resource definition. Once you apply that to your cluster, you get a set of APIs. So with Kubernetes you can create APIs on the fly, and once you have that CRD in your cluster, you can create these custom resources, and you can do things like list, put, patch, delete, so many things. So Kubernetes will help you extend the Kubernetes API, create your own APIs, and this is how we extend Kubernetes basically to fit any use case you want. Now there is something called controller. So what controller does is it continuously watches a resource, in this case a custom resource that you create or some third party application creates. So it is continuously in a control loop watching this resource, and once that resource is created, updated, deleted, whatever, it does something, and that something is making some Kubernetes API call. This is what a controller does. So for example, if you have worked with Kubernetes, you create a deployment and then you maybe change your replicas from 1 to 2. Behind the scenes a new pod gets created. Who creates it? There is a controller which watches for deployment resource, and then it then does something and increases an extra, basically creates an extra pod and things like that. So there is a controller which does things. This was a controller which watches the deployment resource. With Kubernetes you can create your own controller that will watch for some custom resource. It can watch for multiple resources as well. Now there is something called operator. This is where we'll focus. So operators are similar to controllers in the sense they also continuously watch a custom resource, but instead of making Kubernetes API calls, they can do anything that you want. So if how many of you are familiar with Helm charts? Okay, a lot of you. So Helm charts is basically a standard way of deploying applications to Kubernetes, right? So let's say you have a Helm operator, something that you created on your own, or maybe some other somebody else has created. So what a Helm operator will do is it will have some custom resource it continuously watches, and based on this it will create a Helm chart or update it or maybe delete it. That is what a Helm operator would do. If you are working with databases and there is a database operator, so a database operator would do whatever operations you will be able to do with a database. For example, maybe a custom resource changes or is created, deleted. It will maybe create a backup of the database or restore a backup or do things like clearing a cache or whatever, right? So a database operator would do whatever you can do with a database. Similarly, an Opensearch operator would do what you can do with Opensearch. So things like if you create a custom resource for an Opensearch operator, the Opensearch operator behind the scenes, it will look for this, it will detect, okay, a new resource has got created, I will now deploy an Opensearch cluster. It can deploy Opensearch clusters, it can add nodes, reduce nodes, control the amount of resources, CPU, memory, create alerts, dashboards and so on. So it can do a lot of things. So the one thing I want you to take from this slide is that Kubernetes operators basically mimic a human operator. So if you have a database operator, they will mimic what a database operator would do. So Kubernetes operators would mimic human operators. So whatever a human does for operating or managing a particular service, a Kubernetes operator will do exactly the same. It will automate everything. You still have control, you can do trigger based, so whenever something changes, do something like reactive, right? Similarly, an Opensearch operator would mimic what a human Opensearch operator would do. So let's say you have an Opensearch cluster, you are maintaining it, whatever things you have to do on your day-to-day basis, let's say it is rolling over an index or clearing an index, creating a dashboard, an alert, notification policies, things like that. All of it can be done by any Opensearch operator. In this case, there is a GitHub project called Opensearch operator, which is an Opensearch operator. So we'll be talking about that in this presentation. So Opensearch operator is an Opensearch operator, and it basically helps you deploy, update, configure, and even delete an Opensearch cluster or multiple clusters if you wish to do so on the same Kubernetes cluster. So let's see how this particular thing looks like. So this was the first architecture I came up with when I wanted to deploy Opensearch on Kubernetes. So there are two parts to it. One is Fluent Bit on the left and on the right maybe. And on the left you have Opensearch. So let me talk about Opensearch first. So first of all, you have to deploy something called Opensearch operator. And you can deploy it very easily. You can deploy it manually. You can deploy it through Helm. So I used Helm to deploy Opensearch operator. Behind the scenes, it also deployed a lot of custom resource definitions, CRDs that is. And now once that is done, nothing is there yet. Now I will create a custom resource. That custom resource is called whatever Opensearch operator decides it to call. So it is something like OpenSearch cluster.opensearch.io, something like that. And you create a custom resource. There you specify how many nodes you want. What is the CPU requirement? What is the memory requirement? What is your Opensearch dashboard config? Whether you want to use auth0 or SSO or something like that. Everything can be specified there. Once you specify it over there, behind the scenes, Opensearch operator will talk to Kubernetes. It will create things for you. In this case, it creates your nodes and your Opensearch dashboard. So nodes are like stateful sets. So you also have storage attached to it. You can also configure the storage obviously in the custom resource. So it will deploy all of these nodes for you. It will also deploy a dashboard. So the dashboard will talk to the nodes. All of this is managed. You don't have to worry about anything. You want TLS, there is already a certificate there by default if you don't wish to provide one. So behind the scenes, everything is managed for you. You don't have to worry about anything. All you have to worry about is creating this custom resource. In this custom resource, whatever you write is going to be deployed in that way. So if you want 3 replicas, it's going to deploy 3 nodes. If you change it to, let's say, 5 replicas, it's going to deploy 5 nodes for you. Everything is handled automatically. You don't have to worry about anything. Now, once I deployed this Opensearch cluster using operator, what I did was then I created a load balancer. So my users could go through the load balancer and the load balancer would direct traffic to the Opensearch dashboard. I had used SSO. So basically, any user who wants to access Opensearch basically goes through the load balancer to the dashboard and then they can interact with the cluster. Now, how do you send logs to this? So there is something called Fluent Bit. So Fluent Bit runs as a daemon set, and what that means is it is deployed on every node of your Kubernetes cluster. So what happens is in Kubernetes cluster, all your containerized workloads, whether it's deployment, pods of deployment, stateful set, daemon set, anything, all of them are essentially running as containers on your nodes. And the container runtime that runs on these nodes, it is storing all the logs that your application is printing to some place on the node, right? Var logs, whatever, could be anything. Now what Fluent Bit will do is, it will run on every node. It will look at that path where the logs are being stored, and that is basically its input. So it has input and output. So its input would be these log files that get created by the container runtime on the nodes. It will read all of it and send it to Opensearch. So there is also an Opensearch service that gets created automatically. You can also create it manually, and I won't go in depth about it. It's basically Kubernetes stuff. So an Opensearch service gets created automatically. In Fluent Bit, all you have to do is configure the output part of it to Opensearch. You can configure the ports, certificates, everything. So essentially in Fluent Bit, you are defining 2 things, input and output. Input is your logs that are created by your applications, whether it is you who has written them, whether it's some third-party application, whether it is something by default that Kubernetes runs, could be anything. All of the logs are basically sent to Opensearch through Fluent Bit. So input is all of these logs, output is Opensearch, and this is how it works. And this approach is fully end-to-end. You don't have to do anything more. So you already have Fluent Bit, which is getting the logs. You have Opensearch where the logs are getting stored. You also have Opensearch dashboard through which the users are interacting with the cluster. You also have load balancer optionally. If you want to restrict it in the network, you can do various things. Now you also have your workloads here. I mean, workloads are the ones that are generating the logs. With Fluent Bit, you can also look at the logs of Fluent Bit and Opensearch as well. So this is how it works. It is fully end-to-end. There is nothing more to be done here. But this is only for a single cluster. So this works great. It worked great for me. But then I don't have a single cluster in my organization. I have multiple clusters. Or if you have a single one, it works great for you. But when you scale to multiple clusters, this is where when a problem comes. So now if you have, let's say 5 clusters, will you deploy Opensearch 5 times in every cluster? Maybe you can, but that is not a very efficient way to do things, because let's say you created a dashboard in one, you would have to do it 5 times. When you want to query for logs across clusters, how do you do that? You have to run that same query multiple times. So deploying it in a single cluster is fine as long as you have a single cluster. But when you scale, when you have multiple clusters, that's when you have to do something. So I did those changes, and this is how the updated architecture looked like. So now there are 2 parts to it. One is your Opensearch cluster where Opensearch is deployed. There aren't many changes there. The other is edge cluster. So think of a hub and spoke model where in the center you have this central Opensearch cluster, and all of these other clusters are at the edges, and they are essentially pushing logs to the central cluster. So how does that work? So here nothing else changes. This Fluent bit is simply pushing the logs to Opensearch. Now on the edge clusters, what happens is you will only have Fluent bit. You have your Kubernetes workloads in both the places. What Fluent bit will do is there is absolutely no configuration change, except instead of pushing to this internal service. So previously this Fluent bit was pushing to this Opensearch internal service. Now it is going to push to load balancer. That's it. On the load balancer, what I did was I put a configuration saying if I get logs on, let's say, port 9200 or whatever the default port of Opensearch is, if I get logs, they are just forwarded to the Opensearch nodes in this case. And if I get a user request, just forward it to the dashboard. So I did something like Opensearch dashboard.company.com and opensearch.company.com, something like that. So you obviously have the choice to whether you want to create a single load balancer or multiple load balancers. That is up to you. I used a single one in my case. So all the traffic that I was getting from the users, it was simply being directed to the Opensearch dashboard, and any traffic that I was getting from these Fluent bit instances from different clusters, Kubernetes clusters, it was going to the nodes, and this is how it was working. And this was perfectly fine. Now I have a single place where I can query all my logs for all my Kubernetes workloads, irrespective of which Kubernetes cluster they are living in. But the problem is, how do you know which Kubernetes a particular log is coming from? So in Fluent bit there is this special thing where it can enrich your logs with Kubernetes metadata. So by default, what Fluent bit would see is basically a log file and logs, right? Nothing more, maybe a timestamp, that's it. What Fluent bit will do is it will query the Kubernetes API, it will fetch information. So this particular log file or log line, which container does it belong to, which pod does it belong to, which namespace does it belongs to, what is the image ID, and so on. So these Fluent bit instances are going to enrich your logs with Kubernetes metadata. So when you search for logs on Opensearch, you not only get the logs, but you also get the context in the form of Kubernetes API, Kubernetes metadata. So you will come, if you want to find all the logs of a particular Kubernetes pod, you can do so. But what if you have multiple pods? You can also add labels to your pods and send them as metadata. So now if you have a workload, let's say Nginx, if you have deployed Nginx on Kubernetes cluster, you put some label for all the pods that Nginx creates, let's say component equal to Nginx, and you can search for those labels also in Opensearch because Fluent bit has added that metadata. So you can add custom metadata as well. The more you add, obviously the more overhead it will be, but you can decide how much to add, what to add, and based on that you can search for logs irrespective of knowing whether it's coming from a pod, right? You don't even have to know whether it is running Kubernetes underneath, as long as you provide correct filters. So this is how it was working, and it was perfectly fine for me. It was working superbly until it did not. So what issues did I face? Now when you have a single cluster here and you have multiple edge clusters, it was working fine. But what happened was we created more clusters. So when we created more clusters, we had more logs. When we had more logs, the log volume increased. We also scaled existing clusters. So whatever clusters I had, they went from 5 nodes to 10 nodes, 15, 20, 50. So the number of nodes increased. As the number of nodes increased, the log volume also increased. Then these individual Kubernetes workloads, the number of replicas increased. So as the number of replicas of Kubernetes workloads increased, the number of logs also increased. Next, we were deploying multiple Kubernetes workloads. So as that increased, the log volume also increased. The developers now, when they wanted to debug something, they increased the log verbosity from info to debug, for example. So when your logs also increase, obviously the log volume is going to increase. So the log volume was continuously increasing. At one point, what happened was, Opensearch FluentBit was trying to push all the logs, and there came a limit that it was just not able to push a lot of it, because Opensearch simply rejected it, did not have that much capacity. So you can say that Opensearch nodes maybe, or the load balancer. So there are multiple single points of failures. So a lot of things can happen. Your Opensearch nodes could crash, but in my case, mostly FluentBit was crashing because it just couldn't push a lot of logs. So what to do in that case? You can obviously scale up your network, scale up your nodes, but there are certain limits to scaling, vertical scaling or horizontal scaling. And I wanted to actually look for a better solution. So how did I do it? Enter Kafka. So what I did was, before the load balancer is pushing logs to the Opensearch nodes, I just put a Kafka queue in between. So now, FluentBit pushing the logs through load balancer, it is now going to a specific Kafka topic. In this Kafka topic, everything is being stored. There is another FluentBit instance. It is reading from this Kafka topic and then pushing logs to Opensearch. Now it looks easy, but here FluentBit is used in 3 different configurations. This is configuration number 1, where input is your logs, log files on the nodes, and output is Opensearch. There on the edge clusters, the input is the log files from the nodes, but the output is not Opensearch. Output is Kafka, which goes through the load balancer. So now load balancer has to do routing multiple times, one to Kafka, one to Opensearch dashboard. So when it goes to Kafka, it gets stored there, and then it is being read by another FluentBit worker. Now this is not a daemon set, it is a single worker. You can scale it to n replicas, but it won't be running on every node. Now for this FluentBit, the input is Kafka and the output is Opensearch. So you have FluentBit running in 3 different configurations, and this is how my architecture looked like, and this was working fine. But there are certain issues also with this. So for example, when I'm pushing logs, everything is getting queued in Kafka. So at least nothing is crashing, but I'm getting a certain latency now, because now things are being pushed to Kafka and then being read asynchronously, let's say, by FluentBit. So if the logs are from this cluster, it is almost instantaneous that I get the logs in Opensearch. But if it is for other clusters, there is some time lag, and that time lag increases as your log volume increases. So this was one issue which, so I fixed that as well in my next iteration, and this is what it looked like. So now, instead of using FluentBit, first of all, in Kafka, I used my own some custom worker that I wrote. Everything else is still the same, but why did I write this custom worker? With FluentBit, there are certain limitations you get. So by default, you can configure, right, what exact index to put on and what should be a rollover and everything. But you can't do a lot of filtering. So FluentBit is limited in that sense. It uses very less resources, true, but though there were certain limitations. I could configure it to some extent, but then I also had, so I had this special case where so what the developers did was, they wanted to run some performance test. So I had created an IDP for them. So basically they clicked a button and created this entire environment on a Kubernetes cluster, which ran the test automatically. Once the test is done, it will post some results. It will also generate logs, obviously, and those logs will be pushed to Opensearch. Now, for them, these logs are useless until and unless their test does not perform well. So if the results are below threshold, or if there are certain errors, only then would they see the logs. So what I did in this case was, I pushed those particular logs through my custom workload to some index which I did not care, and this index was like very short-lived. So every 7 days I was just deleting the entire index basically. whereas certain workloads were production, right? So they had to be there. We did not want any latency for that. So what I did here is, so for production level workloads or clusters, the logs came through the load balancer and directly to Opensearch. So in this case, the fluentd, the output was Opensearch itself, but it was going through the load balancer. For certain environments which were not production, staging, UAT, development, testing, all those things, it went through the usual route of through the load balancer into Kafka, and then the custom workload would simply read all of it and then push to Opensearch. So for production workloads, the latency is very less now because everything is directly going to Opensearch. For non-production workloads, it is going through Kafka, and there is some latency, but it's okay because it's not production. And there were some other workloads as well where I just did not care much about the logs. So it's fine if they were like delayed by many minutes or even hours. I did not care because nobody else looked at those logs until and unless the test was completed, and that took like few hours, 6 to 7 hours. So for those cases, it was fine that the logs would come late because anyway I'm going to delete them in the next few hours or days, whatever. So this is how my final architecture looked like. It is slightly complicated because there are a lot of moving parts. I used FluentBit in most of the places except where I could not because there were limitations. So this is how the architecture looked like. Anybody has any questions on this? Yeah.
Can you clarify what's the difference between the fluent bits on the left versus the right? Because I know the left ones were there in your initial architecture.
Right.
So I just wanted to clarify like why they're still there and what function they're playing in this one.
Yes. So in these clusters, you need FluentBit because they are reading the logs and pushing to Opensearch. What about this cluster? You have logging enabled in every cluster, but you also want logging in your cluster where you are running Opensearch, right? So for logs generated by FluentBit of this cluster, by Opensearch of this cluster, or any workloads that are running on this cluster, you want logs for those workloads as well, right? And for that you need FluentBit because Opensearch is not directly going to read logs. Somebody needs to push it, and FluentBit was basically pushing logs.
Okay.
Yeah, any other questions? We can take questions at the end as well if you wish to. Okay. So an interesting question comes up usually is FluentBit is FluentD. Both are open source projects. Both are used for pushing things, pushing logs, especially Kubernetes logs, especially to places, Opensearch included. So what is the difference? So first of all, this big bird that you see, that is FluentD, and the smaller one is FluentBit. One of the reasons is that FluentD typically uses a lot more resources as compared to FluentBit. But with FluentD, you can do a lot of filtering as well. FluentD has a lot of destinations and inputs that it can support. But for FluentBit, there are very few. Opensearch is one of them, and that's the reason I decided to go with FluentBit. But if let's say you want to push logs to multiple places and that one of those places is not supported by FluentBit, you would typically use FluentD for that. What usually people do is they use a combination of this approach. So in your Kubernetes cluster, FluentBit is reading all the logs, but instead of pushing it to Opensearch or something, it is pushing it to FluentD, which is deployed in the cluster, and then from FluentD it is going to whatever destination. You can also do filtering. You can do filtering in both as well, but in FluentD you have much more power to do filtering. You get a lot more powerful filtering. But ultimately I decided to use a custom workload because of my use case, but I did use FluentBit in multiple places. So if you are confused between one of these, maybe go for FluentBit and then check the performance and then do the same for FluentD. Use whatever suits your use case the best. If you have multiple destinations and if the destinations are not supported by FluentBit, you would typically go for FluentD. But with FluentD, the memory resource is slightly higher than FluentBit. It is not a lot, but it is still on the higher side as compared to FluentBit. FluentBit uses very less resources. So coming back, so this entire thing was deployed by Opensearch operator, at least the Opensearch part. The FluentBit part was deployed separately. But what can Opensearch operator do for you? It can, first of all, it is going to deploy Opensearch clusters for you. If you want 5 nodes, 6 nodes, just have to specify nodes colon 5, 6, 7, and it will deploy everything for you. So OpenSearch operator, step 1, it is going to deploy things for you. Deploy OpenSearch, clusters, nodes. You can define the resources, how many resources, how much CPU you want to give your OpenSearch nodes, how much memory you want to give it to them, how many replicas should you have. So do you want 5 nodes, 6 nodes? You can do the same for OpenSearch dashboard. So OpenSearch nodes are like stateful, whereas OpenSearch dashboard is kind of stateless. It is created as a deployment. You can scale it individually. So here you can specify how many replicas you want. Internally, OpenSearch dashboard talks to OpenSearch nodes, obviously, and you don't have to do any configuration for that. Everything happens automatically because of OpenSearch. So OpenSearch operator, it does all that Kubernetes magic behind the scenes for you. TLS config. So obviously, you want TLS. You should have TLS or SSL defined in your cluster, in your OpenSearch dashboard, as well as in your OpenSearch nodes. And if you wish to do so, you can specify your own certificate. If you don't have your own certificate, it can create one automatically for you. So the next time you want to interact with the OpenSearch API, you can use those TLS. Everything is available through Kubernetes, so that's there. You can define your credentials. You can define what are the basic set of users that you want. So by default, when you deploy OpenSearch, you get certain users with default passwords. So you obviously want to change that or just delete those users. You can do so directly by configuring it in this custom resource that OpenSearch operator gives you. So all you have to specify, what are my users, what are their passwords, and that's it. It will deploy those for you. If you don't specify anything, it creates the default set, which you should just remove those and create your own, or just rely on SSO or something. So you can also do SSO, any kind of auth configuration. Everything is possible through OpenSearch operator in this custom resource. So just specify what is your client ID and client secret, tenant ID, all of those things, and it will deploy everything for you. You can also specify what roles you want. So based on your auth provider, you can have groups, and then everything is done. Everything is possible. Next, define dashboards. So typically what people do is deploy OpenSearch, then define the dashboards. With OpenSearch operator, you can by default define the dashboard. So if you already know what kind of dashboard you want, you can automatically deploy it through the operator. If you don't know, you can simply deploy the cluster first and then make modifications to this custom resources, and it will deploy the dashboard. Similarly, you can do for action groups, tenants, ISM policies. I am using the ISM policies a lot. So for example, if you want automatically delete something or move to some other storage tier, you can do everything through Kubernetes. Define the resource, define everything what you want. It's simply a JSON or a YAML, and OpenSearch operator will do everything behind the scenes for you. It will talk to OpenSearch in your place. It will do everything for you. So this was one of the most confusing things for me when I first started with OpenSearch. This VM max map count. So you have to go to the node and then do some changes, increase it to some particular value. OpenSearch operator will do it for you directly. So you don't have to mess with it. You don't have to go into the nodes or create some custom way of doing things. Everything happens for you. You can create plugins. Also, any kind of configuration you think of, OpenSearch operator can do. And auto scaling is not there yet, but they are going to implement auto scaling soon. So now you don't even have to worry about scale, because everything can be done through OpenSearch operator. So what were some of the challenges that I faced? It was very time consuming. It's not like day 1 deployed in the cluster, day 2 bring more clusters, day 7 everything is done. It was time consuming. This was not my primary project, so I also had other things to focus on. Knowing the internal workings is important, because how are you going to manage a service if you don't know how it works, how to scale it, how to provision it, and so on. So knowing the internal workings is really important. Next was very specific, that static versus dynamic mapping. So this is also a part of the internal workings. So the developers, they had very horrible logging practices. So dynamic mapping was failing a lot of times, so we had to move to static mapping, force the developers to log things properly, log it in a certain way. And there were many other challenges as well. And next is your entire logging pipeline. Now you have it. How do you know it's working to its optimum condition, or how do you know it is failing or going to fail? You need to monitor it. You need to know exactly which metrics to monitor. You need to know how much to monitor, because monitoring will also take up your resources. So know what exact things to monitor, know what metrics to monitor, and actually monitor it, look for it, create alerts and so on, create dashboards. So just know all about the metrics, so you know how well your thing is performing. Any questions? This is the end, so yeah.
As per my knowledge, FluentBit is a log shipper, right?
Yes.
It won't save the logs
It
application.
won't save the logs, correct. It will ship logs.
But as per that architecture, right, from FluentBit to sending the logs to Opensearch.
This one?
Yeah. In
Yeah.
that Opensearch is in case down on the time, application logs where it is stored.
So when Opensearch is down,
In case.
FluentBit will fail obviously because it cannot push. You have Kafka there, so at least for those clusters, the logs will get stored in Kafka until Opensearch comes back up and it's get pushed.
Yeah.
But for these things, it will fail. So you probably
Yeah.
want to do some Kafka or something else.
In the particular interval of time, definitely some logs going to miss, right?
Correct. So what FluentBit does is it retries. You have exponential backup, all the things you can think of, everything is there. But of course, if your Opensearch is down, then yeah, you will lose some logs. Correct.
Yeah. In the production, that is big loss on that time.
Correct. So you may want to do something else, like maybe Kinesis or something, Kafka, multiple options. But yeah.
Okay. Thank you.
You mentioned that you are using Kafka service, right? When there is a high load on the Opensearch, so that we don't miss any logs.
Correct.
But these log collectors have an option of buffering, right? You can buffer the logs so that we don't miss any logs. Is there any advantage of using Kafka over it?
So Kafka I used because I just wanted some of my logs to come a little late, and for production I directly wanted them. So Kafka you can use buffering as well, but then again, so when you do buffering, are you pushing it directly? If you're pushing it directly, Opensearch goes down, everything is stored in buffer, which is temporary. Kafka is a slightly more permanent in that sense, but you can do buffering as well, yes.
Yeah, but Kafka doesn't give that advantage, right? You can just increase the storage of the Fluentd volume, and you can store a volume.
Yes, but yeah, you can do that as well.
Yeah.
But for me, I just want everything to be as stateless as possible. I just want to reduce my stateful workloads. So that's the reason I went with this queuing approach. But you can do buffering as well.
Okay.
By default, there will be buffering in FluentBit and even Fluentd.
Yeah.
But yeah.
Thank you.
It's working. Hey, I just had one question. So you built a Kafka subsystem through which you are probably pushing all the low priority logs or something like that. Did you think about creating another smaller Opensearch cluster and use Opensearch dashboards as a single stop shop for both these clusters? Because Opensearch dashboard supports connecting multiple clusters at once, right?
Yes, but I went with Kafka because my thing was more of a queue based.
Okay.
Eventually, I moved from Kafka to Kinesis also, but that is a
Okay.
whole different thing. But yeah, I just wanted a queuing system which is very easy to maintain and don't have to do much.
Okay.
Kafka suited me best.
Hey, thanks for the talk. So, can you explain how did the scale in or scale out happened when the load increased or decreased? How did you add nodes, or did you scale up, or did you scale out?
Yeah, so with Opensearch operator, scaling is very easy. All I have to do is increase replicas from 3 to 4, 4 to 5, and it just creates more nodes. You can specify your CPU memory configuration. It will automatically do a rollout restart. These are all Kubernetes terms. So everything is handled by Kubernetes ultimately. Opensearch operator is just like a tool to do that, and you can simply add more nodes, increase the existing nodes. In my case, there was certain limit beyond which I couldn't scale, and that's why I implemented this queue system. But you are free to do so. You can simply give more resources.
So, do you have to add it manually, or there are ways in which you can have some feedback loop which does it for you?
So this loop is already there in Opensearch operator. All you have to do is increase the replicas. That's it. One API call. And now with auto scaling, you won't even have to do that. But that is still for the future. So all you have to do is make an API call. It's like pressing a button and more nodes simply come up. You can use Kubernetes tooling also to scale it, but that's up to you.
Hey, awesome. I know a lot of questions still unanswered. Pratik will be available outside. Please feel free to connect with him and continue to discuss this further questions. Hey, thanks,
Thank you
Pratik.
guys.
Thanks, team.